Hello, viewers. In today's class, we are going to discuss yet another important and conceptual problem from integral inequalities. So, here once again, we have a very important problem from integral inequalities. So, here we have to show that the absolute value of the integral 0 to 1 square root of x square plus x dx is less than or equal to square root of 3 over 2, right? So here without calculating the value of the integral, we have to show that the absolute value of this integral is less than or equal to square root of 3 over 2, or in other words we can say that the absolute value of this integral, it doesn't exceed over square root of 3 over 2, right? So let us start. So let us call this integral as I, right? So we have I is equal to 0 to 1, and the integrand is the square root of x square plus x dx. So we have to now show that the mod of this integral, that is mod of I, is less than or equal to square root of 3 over 2. So now to prove this inequality, here we'll make use of one important result from definite integrals, right? See, if we have two functions, say f of x and g of x, which are integrable and continuous in the closed interval a comma b, right? And if f of x and g of x are continuous function in the closed interval a comma b, and the square of this function f of x is also integrable, and similarly the square of this function g of x is also integrable in the interval a comma b, then we have a very nice result which is known as Cauchy-Squarz inequality, right? So the Cauchy-Squarz inequality states that the absolute value of the integral, that is a to b of f times g dx, right? The absolute value of the integral of the product of the function f and g from a to b is less than or equal to square root of the product of these two integrals. That is, the first one is from a to b, and here we have f square dx, and here we have a to b g square dx, right? So this inequality is known as Cauchy-Squarz inequality, and here the absolute value of this integral a to b f times g is less than or equal to the square root of the product of the integral, that is f square dx from a to b and g square dx from a to b. So we'll apply this result to prove this inequality. So now let us concentrate on this integrand. So here we have square root of x square plus x, which can be written as x times x plus 1, and here we have dx, right? So we can further write this integrand as square root of x times square root of x plus 1 dx. So why we have expressed square root of x square plus x like this? Because we can take this function as f of x, or simply f, and this function as g of x. So we can take f of x as square root of x and g of x as square root of x plus 1, right? So now we can apply this inequality to these two functions, that is f and g. So now we can write the absolute value of the integral, that is a to b. A is 0 and b is 1. So we have 0 to 1, f is square root of x, g is square root of x plus 1, and here we have dx. So this is less than or equal to the square root of the first integral, that is from 0 to 1, and here we have f square, right? So square of f is equal to x, right? So here we have simply x dx, and the second one is g square dx. So the square of the function g of x is x plus 1, right? So here we have 0 to 1 x plus 1, and this is dx. So now let us separately calculate these two integral. Let us call it as I1, this is I2. So I1 is integral 0 to 1 x dx. So this is x square over 2. The limits are from 0 to 1. So we have half minus 0, that is equal to half, right? And here I2 is also a simple integral. So we have I2 as 0 to 1 x plus 1 dx. So this is x square over 2 plus x. The integral of x plus 1 is x square over 2 plus x, and limits are from 0 to 1. So when we substitute the limits and we'll take the difference, we have half plus 1 minus 0 plus 0, that is 0, right? So this is 3 over 2, right? So now this inequality can be rewritten as mod of this integral. This integral is our I. So mod of I is less than or equal to square root of I1 and I2, right? So this is square root of I1 is half, and I2 is 3 over 2. So now mod of I is less than or equal to square root of half multiplied with 3 by 2. So this is square root of 3 over 4, that is square root of 3 over 2. The square root of 4 is 2, right? So this is how we have obtained this inequality, that is the absolute value of the integral I is less than or equal to square root of 3 divided by 2, right? So viewers, this is how, by making use of this important integral inequality, we can solve these kind of integral inequalities.